Hey everyone, welcome back. Today we are tackling a really fascinating race condition, the subscription out-of-order webhooks problem. Right now, our server processes every Stripe webhook as soon as it arrives. The problem is that webhooks don't always arrive in the same order they actually happened. Network delays or automatic retries can cause older events to arrive after newer ones. For example, a subscription may first become past due because a payment failed. A minute later, the customer updates their card. The payment succeeds and the subscription becomes active. If the delayed past due webhook arrives after the active webhook, our server will overwrite the correct status with the outdated one, leaving the customer incorrectly locked out. We'll solve this by implementing a time guard. Instead of blindly processing every webhook, we'll compare the timestamp of the incoming Stripe event with the timestamp already stored in our database. If the incoming event is newer, we'll update the database. If it's older, we'll simply ignore it. This ensures our database always reflects the latest subscription status, even when webhooks arrive out of order. Let's not waste any time. We are jumping straight into the Develow code editor to get this sorted out. Let's break this down one failing test at a time. Our first failing test is telling us that older events are currently overwriting newer ones. I know we need to compare timestamps, but let's ask Develow for the safest way to implement this logic. I need to prevent older webhooks from overwriting newer subscription data. How do I properly check if an incoming webhook event is stale compared to what is already in my store? Okay, here's how to implement this correctly. First, figure out which two timestamps you're comparing. You've got the incoming timestamp, which is the event's created time that's the variable you're calling TS in your file. And you've got the stored timestamp, which is the updated at field on whatever's already saved for that subscription ID. If there's nothing stored yet for that subscription, just treat the event as new, since there's no prior timestamp to compare against. Second, nail down the exact rule for what counts as stale. The requirement is that an update only applies if it's strictly newer than what's stored. So if the incoming timestamp is less than or equal to the existing one, that event is stale and should be ignored. It only counts as fresh if the incoming timestamp is greater than the existing one. That equal to part matters if two timestamps are exactly the same. Treat that as stale too, not fresh. Third, make sure stale events don't touch your stored state. When an event turns out to be stale, you should leave the stored record for that subscription completely alone. Don't modify it. Instead, return a result indicating that it wasn't applied, with a reason of stale. On the other hand, when an event is fresh, you go ahead and update the stored record with the new status, price, and updated timestamp, and return a result saying it was applied, along with the new state. Fourth, watch out for the case where nothing's been stored yet. If there's no existing record for that subscription, then the existing updated time is going to be undefined, not a number. So your comparison logic needs to handle that safely, for example, by treating a missing timestamp as negative infinity, or by just having a separate branch that says, if nothing exists yet, this is automatically fresh. Fifth, make sure this actually satisfies what the tests expect. In the failing test, a newer event with a created time of 200 comes in first, and then a later arriving event with a created time of only 100 comes in after it. That second event should be ignored, meaning its applied flag should come back false. And the stored price should still reflect the value from the 200 event, not get overwritten. So the key thing is, your staleness check has to happen before you ever write to the stored record, not after. Okay, that makes perfect sense. We just need a simple if statement to check if the incoming TS is less than or equal to the updated that we already have saved. But before we write the code, let's look at our second failing test. Our system expects a very specific response when we reject a webhook. Otherwise, the test fails. Let's ask Develow our second question. If I detect that a webhook event is stale based on the timestamps, exactly what should my function return to satisfy the system and safely leave the state alone? Now, for the stale webhook case specifically. When a webhook comes in and it turns out to be stale, meaning the incoming created timestamp isn't strictly newer than what's already stored for that subscription, your function needs to do two things. 1. It should not change the stored record for that subscription at all. Leave it exactly as it was. And 2, it should return a result object saying applied is false, with the reason being stale. That lines up with the spec, which basically says, return a result indicating it wasn't applied, tag the reason as stale, and don't touch the state. And just for contrast, the fresh path works differently after you update the store. You return a result saying applied is true, along with the current state for that subscription. So the bottom line is, if you implement that stale return exactly the way it's described, and you make sure you're not writing to the stored record anywhere in that stale branch, then the test that checks a late arriving event doesn't overwrite newer state should start passing. Perfect. Now we have both pieces of the puzzle. We know how to detect the stale event, and we know exactly what to return when we find one. Let's jump into webhooks.js and write this fix. Alright, let's review what we just built. Right before we blindly update the store, we added a crucial safety check. First, we check whether we even have this subscription on file yet. If we do, we then check whether the incoming timestamp is older than or equal to our saved updated time. If it is older, our new code catches that and immediately returns a result saying applied is false, with the reason set to stale. The function exits early, our fresh data stays protected, and the stale webhook gets safely thrown away. With that logic in place, let's run our tests. Awesome, all green check marks. Our initial state applies correctly, newer updates apply successfully, and most importantly, stale, out-of-order webhooks are rejected. Great job, and I'll see you in the next one.